Hi friends, good morning. Welcome to our chemistry class. In our previous class, we have discussed about heptacity. Actually, the heptacity is very important to understand our upcoming classes. Okay, today we are going to discuss about 18 electron rule. Okay, see, if a complex is said to be stable means it should follow 18 electron rule. Then only that particular complex is said to be stable. Okay, how can we find number of electrons in that particular complex means this is actually the formula, just like formula we should remember. Okay, see, sum of metal d electrons plus electron donation by ligand plus overall charge on complex. Okay, means first we have to count the electrons present in the d orbital of that particular metal. Next, we know that ligands have donating tendency, so here we have to count the donating tendency of ligand. Means just here we have to count the number of electrons which the ligand is donating. For an example, if we find carbonyl, means we know that the donating tendency of carbonyl is 2 electrons, like that. Next, overall charge on complex. Yeah, means if we sum all these three, means d electrons and electrons donated by the ligand and overall charge on the complex, it should be this. Means ns2 np6 n minus 1 d10 means, see, ns2 means 2 electrons, np6 means 6 electrons are present in p orbital, so 6. Next, d10 means 10 electrons are present in a d orbital, so totally we get the 18 electrons. So if we get 18 electrons in a particular complex, then that complex is said to be stable. Okay, I hope you understood. Next, okay, geometry. Okay, means if they have given octahedral complexes, OH means octahedral, TD means tetrahedral, TBP, this is trigonal bipyramidal. See, all this octahedral or tetrahedral or trigonal bipyramidal complexes, if they have the 18 electrons means if they possess or if they have the 18 electrons, then that complex is also said to be stable. Yeah, this is actually the most important point we have to remember. If they have given square planar complex or the square pyramidal complex, and if we count the number of electrons, we may get 16 electrons. So we should not think that here only 16 electrons are present, so that this may not be stable. That is not correct, because in case of this square planar and square pyramidal complexes, even if 16 electrons are present, then also these complexes are said to be stable. This is actually the most important point which we should remember. Okay, this octahedral, tetrahedral, trigonal bipyramidal complexes are stable if they have 18 electrons, whereas this square planar and square pyramidal complexes are stable when they have 16 electrons. Okay, next, see, if main group organometallic compounds are there means, we know that main group elements means S and P block elements. So in these cases, these main group complexes are said to be stable if they follow octet rule, not 18 electrons rule. 18 electrons rule only in case of transition metals, like that. But in case of this main group elements, if they have 8 electrons means if they follow the octet rule, then they are said to be stable. Next, this is the most important point, friends. See, lanthanoids and actinoids do not follow any rule, means they do not follow either electron rule, means 18 electron or 16 electron or octet rule. Okay, these lanthanoids and actinoids do not follow any rule, means they doesn't show any rule. Okay, next, yeah, this is actually the most important concept of today's topic. Okay, see, already we learned how to find the number of electrons, so just based on this we can easily find the number of electrons present in that particular complex. See, yeah, let us understand this. Yeah, if they have given organometallic complex to us, And if we have counted the number of electrons, and here of course think like that, here we got 17 electrons. We know that for this organometallic complex, we know that 18 electrons are required for stability. Okay, but here we have only 17 electrons, means it requires one electron to get stability, so that it will take one electron. So here it is taking one electron. We know that here this is taking one electron, means here it is reducing itself. We know that here it is reducing, means it is oxidizing others. So we can say that this is oxidizing agent. Okay, yeah. So from this we can tell this. See, if valence shell electron is less than 18, means if they have electrons less than 18, means they need one electron to attain stability, so that here they are taking the electrons, means taking the electrons means they are reducing themselves, so they are oxidizing the others. So if the valence shell electron is, means if the number of valence shell electrons are less than 18, means they act as oxidizing agents. This is important. Next, if they have given organometallic complex, and if with the help of this we will find, means we definitely find the number of electrons. If we got 19 electrons, means we know that for stability it requires only 18 electrons, no? So that here it will loses one electron. See, here it is losing electrons, means here it is oxidizing itself. So loss of electrons is oxidation, no? So here it is losing one electron, means here it is oxidizing itself. Loss of electrons means oxidation, right? So here it is oxidizing itself. That means here it reduces the others, so that it acts as a reducing agent. So from this we can confirm that if the valence shell electrons are more than 18, means they act as reducing agent. I think it is clear. Next, see, this is mostly in the case of transition metals like that. In the case of main group elements also we should understand. Okay, yeah, we know that main group elements or the main group complexes are said to be stable if they follow the octet rule. See, yeah, if we have counted the number of electrons, and here we got 7 electrons, we know that to attain stability it required one more electron. See, one more electron it required. So here it receives, means it gains the one electron. Here it is receiving one electron, means here it is reducing itself. That means here it oxidizes the other. So this act as a oxidizing agent. So from this we can confirm that if see, in this case, okay, if the electrons are less than 8, means they act as oxidizing agent. Similarly, if we get 9 electrons, means we know that for stability it requires only 8 electrons, that is octet, no? So that here it is losing one electron. Here it is losing one electron, means here it is oxidizing, so that here it is reducing others. As it is reducing others, it can act as a reducing agent. So we can conclude that if the, means in case of main group elements, if the number of electrons are more than 8, then they act as a reducing agent. Yeah, one more important point, friends. See, yeah, if, means just based on the rule, means which we discussed, this means just based on this we can find the number of electrons, no? So if we get the number of electrons as 16 or 18, means even number of electrons, so we can easily say that they are diamagnetic, means they possess the diamagnetic properties. If we get the number of electrons, means odd number of electrons like 17, 19, means they possess paramagnetic properties. One more important point, friends, there are some metals, of course those metals doesn't possess 18 electrons, means they won't follow